Hi, this is Mr. Beck does your homework. This is question number 4 of the homework on rotational kinematics. This question says a figure skater begins spinning counterclockwise at an angular speed of 3.9 pi radians per second. So that's going to give me the angular velocity is 3.9 times pi radians per second. Now you won't always see it times pi, but in this case, that's the way they give it to you. During a 4.7-second interval, so that's going to be the amount of elapsed time, is 4.7 seconds. She slowly pulls her arm inward and finally spins at 8.9 pi radians per second. So that means that I have an initial velocity, and now I have a final velocity is 8.9 pi radians per second. It's asking for what is her average angular acceleration during this time interval in radians per second squared. And so what we have is an angular acceleration. The angular acceleration is given by the symbol alpha instead of a. And just like my acceleration is the change in velocity divided by time, my angular acceleration is going to be the change in my angular velocity divided by my change in time. So if I'm looking for my angular acceleration, I need my change in angular velocity and the change in time. So the angular acceleration is going to be my final omega minus my initial omega, my final velocity minus my initial angular velocity divided by the change in time. So in this case, I have a final angular velocity of 8.9 pi radians per second, and my initial angular velocity was 3.9 pi radians per second. And all of that is happening in a time of 4.7 seconds. So my angular acceleration, 8.9 minus 3.9, 8765, that would be 5 times pi radians per second divided by 4.7 seconds. And so that's going to give me a value of so many radians per second, because this is going to be radians per second, and that's second. So that'll be radians per second squared, and that will give me the angular acceleration in terms of radians per second squared. So 5 pi divided by 4.7 for me would give me my angular velocity in radians per second squared.